Greetings with everyone. My name is Carlos Andres Estrada, the principal author of the paper An Implementation of an Algorithm for Information Depth Using Deep Learning Techniques, an Ethical Hacking Event. It's my pleasure to present the authors of this paper that are Carlos Andres Estrada, Dr. Walter Fortes, Joyce Denise Castro, and Engineer Daniel Núñez Agurto. We are part of the Department of Computer Science of the Universidad de las Fuerzas Armadas ESPE. We are going to show what is worth and how is the innovation of this paper. Me are a student and the assistant researching in this field of computer science and math computing. The presentation contains four steps: motivation and goals, materials and methods, evaluation results, and finally, conclusions and future work. Okay, what is the background of this subject of this paper that we did about insecurity in systems, on specifically in operating systems, and in specifically in the insecure of antivirus. We have used deep learning methods and we did our neural network based on a math model. Of this way, we have created an algorithm to steal information. Deep learning is the new way of making an algorithm secure. We have analyzed some things that have reals to our presentation. Of this way, we are going to begin what is the explication and what are the problems of that. Okay, what are the problems and what is the principal objective of this study? Operating systems are not prepared for smart attacks. Is it too because the operating systems are insecure and they don't have the enough experience in detect different types of algorithms or different kinds of viruses that can be in a computer? Antivirus cannot detect an algorithm that is able to disable it. Is it too because antivirus don't detect an algorithm if it is right in any language? There are vulnerabilities in the vulnerability system and the operating system, things that make it easy to disable protocols. It's too because the operating system doesn't have the necessary security in their protocols as the two is so easy detect and is prevents of cyber attacks. Our contribution of this study is the creation of an improved algorithm for information depth, which requires no other functionality than an authentic connection. The materials and methods that we use is a deep learning as the principal method of this study, a math model that we have designed, a neural network, and finally analysis modeling. We have been a validation and a presentation visualization. We program the algorithm by exporting a data store saved in CSV, a dataset. This repository contains all the methods to avoid an attack. When the algorithm is executed, it's trained to deactivate all the methods. We have used the Python language programming. Okay. Of another hand, algorithm functionality. What is the principal characteristic of this? We have created a math model based in the ReLU function activation. About this, we have used derivatives to derive each field in this call of these fields of study. If we can see, the character is the different security protocols that were collected in a dataset that is exported in a file .csv containing the different container derivations. The mathematical model allows for ranking and performance improvement based on the number of protocols and tries. What it's about? We have referred on the difference. It's due to the different count of entries and the inputs of the neuronal network. The neuronal network was used to enable the output containing the method for information depth. Explanation of the mathematical model. The equations comply with the respective loss rule. We use 5 layers to allow the algorithm to be efficient and efficient in the analysis of the data. Therefore, the output function generates the following result according to the linear algebra computer, about the rules and about the theory of computer science, and obviously respecting the study of Turing's machine. The previous mathematical model expressed the amount of data by creating an intelligent algorithm based on the ReLU activation function. Is due to L1 ReLU W1 X fact plus A1 plus B1 due to W2 Y fact. It's due to the each step is recursive, and it's so important for our investigation and for researching. The behavior of the mathematical model, which was designed for the study and development of this algorithm, has the following function. This is the function that has been compared with another models in this researching. This is the principal method. This is the ReLU function activation. This was the most efficiency in our researching because it's more quickly. Okay, in another point, we have the explanation of the algorithm. The connection with the server must be established and created. Figure shows the execution of the servers and the performance statistics of the linked computer. We can observe in real time during the execution of the algorithm. On another side, we create a read data algorithm in charge of distributing and analyzing information according to its neural network stored in a Linux server. The Linux server has the opportunity to use the different algorithms, establish connection to the server, run the algorithm, and etc. etc. We use Python and other existing libraries for algorithm programming, with modification in the ReLU. Example, TensorFlow and Matplotlib for the mathematical statistics. We employ a tree-based programming model through the Pandas library. Establish connection to the server is one of the principal steps to read the data. After that, read all data. If antivirus exists, then disable the antivirus, else while data exists due. At the left, we can see, or at the right, we can see the algorithm that we have written. It will be an innovation for the field of computer science. Performance test. The learning network is activated by the automatic connection command when connecting with the computer and establishing a connection with the server. Also, during the process, it analyzes and deceives previous if the information is encrypted or blocked. The analysis is commissioned by layers 2 and 3, so the information is legible and without security. At the end, the OP is already a database with all the information copied and divided according to its relevance. At the right, we have the table that we have the sequence and the statistical computing after and before the algorithm. Before and after, obviously, with speed and efficiency, we have met us with the necessary protocols of Turing machines of uh, Turing's theory. At the right down, we have the statistical curve that says data propagation during the algorithm works. Finally, in the results, we test the algorithm using the neural network phase to evaluate computability, which was executed several times. Second stage, prediction of the model. As described previously, 1125 emails were used for the prediction phase, using the Random Forest algorithm. In evaluation results, we export the input that file analyzed using RStudio statistical software. Also, it allowed us to interpret the processing consumption in a system and its maximum number of data computable as inputs enter the network. The algorithm was working correctly during its execution once the server is coupled with the information. Therefore, the data statistics are increasing. Thus, the existing network distributes the data according to the propagation curve once the algorithm is executed. In addition, the information is displayed and copied automatically. And finally, the results are expected according to the compatibility test. Since the neural network was measured with the Turing test, the efficiency and speed of execution generated are accurate. In the next steps, we have the proofs that validate our algorithm. In the first uh, picture, we have seen the antivirus is activated, and the second one is not. In the picture of my left, we have the connection with the server, cent.4.3.org, that we have created with a Linux operating system running in a VMware virtual machine. And we have the steps. Finally, we have copied all the information in the server. And we have classifier, and obviously we have the principal damage and relevant information. Conclusions and future work. This study focused on designing and implementing an unprecedented algorithm to perpetuate the depth of the victim's information is capable of not being detected by an antivirus. It's because it's a new algorithm and it has not been created before. We have been in the related world that another researcher tries to make something different, but with a deep learning technique is a new innovation of the field of computer science. The algorithm implemented with Python, MATLAB, and R assembled a mathematical model and activation function of a rectifier linear unit, ReLU, as part of deep learning. The algorithm achieves the training of a neural network to eliminate any existing antivirus being indexed by any user. We demonstrate finally the depth and the transmission of all the victim's information to a distributed server. The results demonstrate finally the functionality of this training as a part of an ethical hacking event. The algorithm could become a valid solution to reduce server attacks perpetuating our Windows platforms. As future work, we could plan to extrain this algorithm using machine learning and a mathematical model that uses convolutional networks. It's all about that, and it's my pleasure to have presented my work with my partners. So thank you, and thank you for the opportunity to participate in Congreso Internacional Multidisciplinario de Ciencia y Tecnología, CIT 2021.